What's up? In this episode, you'll learn how to solve day 5 for the advent of code in 2022 with Ruby. Day 5 is called supply stacks, and what we're doing is working with a giant cargo crane to move some stuff around. So this is our input. This is our puzzle input for today, and we're going to sort of like move these elements from one stack to another. And this reminds me a little bit of this project or this problem called Towers of Hanoi. And this is kind of a game where you can move pieces from one tower to another. Now this is a little different because there is no size of disk, but it's similar in that we have some instructions that we're going to receive and we want to move things from one tower to another. So in this first problem, what we're going to do is if we take a look at our input, our test input, sample input here, you'll notice that the first instruction says we want to move one element from tower 2 to tower 1. So we want to move this D from tower 2 to tower 1. And then we'll end up in this second configuration. Now in the second step, it says we want to move 3 crates from stack 1 over to stack 3. But you'll notice that we have to move the crates one at a time. So first we move the D over, and we put that on top of the P. Then we move the N and put that on top of the D. And finally we move the Z, and that ends up on the very top of this third tower. Finally, we're going to move both of the elements from stack 2 over to stack 1. Again, one at a time. So we move the C first, then we move the M, and it ends up on top of it. So for me, looking at this problem, there's two parts of it. One is the deserialization. Like, how do we read this in as text and build up a data structure that will work for us? And then number 2, how do we go through and sort of like execute these instructions in the right order and move them over and to the right towers, etc. So what we're going to do is grab all this, open up our day 5, and at the bottom here, again, we'll drop in our test input. And now what I want to do is let's just start off the smart way. And instead of having to debug a ton, we're going to require rspec auto run, and I'm just going to say rspec.describe. And what we want to do is have a couple different tests. One is going to be like it reads the towers as expected. So we just want some sort of test that's going to help us out here. And so the first thing I want to do is sort of like read in this data. So I'm going to say before all, I'm going to read in like at data at the towers and at instructions is going to be something like data.read.split on 2 new lines. Okay, so this is going to read in all this data down here and it's going to split on 2 new lines. So the first chunk is going to end up in towers and the second chunk is going to end up in instructions. So here, because we're using this like 2 variable assignment, we're going to split, or we're going to deconstruct the array that returns from this split operation into these 2 towers or these 2 data things. And then we can use that and say something like towers is read towers of at towers. And then we're going to do something like expect towers.length to equal 3, because we're expecting that there's going to be 3 ultimate towers at the end. And we're going to expect that towers, like the first tower's length is going to equal 2, because that's going to be just N and Z. We can also make expectations about what's in there. So just to like really help us out with like what, how this is being broken down. So we're going to expect that the first element in this first tower is Z, and the second element is N. Okay. All right, so this should get us going. So we can run this Ruby day 505. Okay, undefined method read towers. So let's go implement read towers. It's going to take in some data. I don't know, some towers. Yeah, let's call it data. And now we're going to say like data dot split. So this tower thing, we want to split it on new line to get each of the different rows. So we're going to say data dot split on new line. And that should give us some rows. That's going to be different than what we actually want though. Okay, expected 3, but we got 4. Okay, the other thing we can do when we're using rspec is if we want some other information about the error, we can add a comma after this equals and just say towers, just so we get like the actual raw data that we can take a look at. So here we see this is what we're actually getting back. So this is pretty good. So we have a couple different elements, and each element right now is sort of like a layer in the stack. It's not a tower, it's a layer. And so we want to sort of just throw away this 1, 2, 3. We don't actually care about the labels. What we're going to do is use the longest row in a layer as the reference to like how long the row is going to be. So now that we have these split on new line, we also want to map these, like we want to map over these and split them again. And in the case of D, or like this first layer, like this D is in the second tower. So we need some way of knowing that, like, okay, if there's 4 spaces, we need to ignore that, but we need to consider that being like a tower or like an entry, so we can keep track of which tower D is in. So what I want to do is say, I'm going to map the line and I'm going to split it on a 4 space white space mark, and let's see what we get here. Okay, great. So now we have the first element is broken up correctly. So now we have an empty string, which references sort of a space above the first tower where nothing actually exists. So this is kind of like representing this empty space. And then we have D, so that's good. If we look at the second row though, we're still not splitting this one up. So in addition to splitting on 4 white spaces, let's also split on a single white space. And we end up like this. So this is looking really good, right? We've got the empty space, we have D, we have N, C, those are split up, and then ZMP is split up. And then we still need to discard sort of this last one. To ignore this last row, what I think I want to do is just reverse the entire array and then start iterating over it so that we're starting from like the base level and working our way up. And then at that same time, we can sort of exclude the labels. So let's say reverse, and then we'll say dot each with index, and each row or level and its index is going to give us something. So now we can say next if I is equal to 0. Just like skip over if I is equal to 0. So each with index is going to yield the elements in the array. It'll also give us this I, which is kind of like just the index that we can keep track of as we go. So we're going to skip over if the index is 0 so that we ignore the labels. And then otherwise what we want to do is now we want to take those levels and we want to like iterate over those. So now we want to say something like level dot each do element. And for each element, we want to skip the element if it's an empty string, right? So we're going to say next if L is an empty string. Otherwise, we need to start sticking these things into a tower. And again, because we're starting at the base, like we're starting them in reverse order, we should be able to like put these into some new array. So let's create a new array called towers that we will return. And this towers will keep track of all of the different towers. So, yeah, so we kind of also need to know which tower we're entering into. So we want to use each with index again here. So we'll use J. So if towers at J is empty, then we want to set it equal to a new array. Otherwise, we're going to shovel the element into the array and let's see what we get. Okay, so I think, or our test output changed, and I think we're like getting close to the end here, right? Like now we're getting this, but we should, yeah, let's just look at what towers looks like at that point too. Okay, so now our towers are set up like this. So we have an array with Z and N, and we have an array with Z and N, that's good. And then MCD, MCD, and finally we have P. So they're all looking great. The only thing that's wrong now is that we still have like the square brackets around these. We got to do some something to remove those. So let's, right here, we can just, I don't know, I think this is a good spot. We'll just say level.map, and we'll say for each element l.gsub, and we will just remove if it has square brackets. And if we run this, boom, passing test. Fantastic. Okay, very cool. Okay, so now we are able to read our towers, and they should be in a format that makes sense and is useful for us. The other step, or like the next step here, is that we need to like make sure that it reads the instructions. So it reads the instructions. Okay, so we want to say instructions is read instructions. And we want to expect that the instructions length is 4. And we also want to, I don't know, we can actually just say like, we expect it to equal something like, I think we just want like an array of arrays where it's like 1, 2, and 1, 3, 1, and 3. And then we'll know like how to implement the move method based on that. So let's say 1, 2, 1, 3, 1, 3, and 2, 1, and 1, 2, 2, 1, 1, 1, 2. Okay. I wonder when GitHub Copilot will be able to listen to like what you're saying and then figure out stuff. Okay, so let's run our tests. Our instruction thing should fail because that method doesn't exist. So let's write a new method here. It's actually, yeah, so def, well, whatever. Read instructions, data. So we're going to say, again, data.split on new line. And then we want to, let's see. So for the instructions, I think we could just use regular expressions with capture groups. So this is another feature of regular expressions where we can say like, oh, if it starts with move whatever from to, yeah, so we want to map it, and we'll say that for each line, we want to match against some thing. And instead of putting 1 here, we can use a capture group, and we'll say n. And n is going to be in some number value. And we'll use the same pattern for each of the numbers. So this is going to be from, and that's also a number. And then this is going to be 2, and that's also a number. And that should match. Okay, so let's just see what we get for read instructions. So we'll just p instructions here and then run our test. And we got, okay, so we get all these match data objects, and you'll notice that when we get a match data object with a capture group, there's these sort of like symbols here, which we can sort of treat as a hash. The match data class has a square bracket operator where we can pass in the name of the matched thing, and we'll get back the value. So this will give us like 1, 2, 1. So that's fantastic. So let's, yeah, so then what we can do is say like, we want to map over the matches and convert them to integers. So we got n from and to I, and instead of getting back a hash, we want to just get back an array. So we'll just say like, give us back an array with all of these 3 things inside the array, and that should be good. So let's see what we get here. Oh, we have a passing test. Fantastic. Okay, so that's how we read instructions. We're just going to read all of the instructions with sort of regular expressions. Now we need a way to actually modify a tower. So we're reading in the towers, we're reading in the instructions. Now we need to apply the instructions incrementally to the towers. So let's write another test down here. We're going to say like it moves elements or something. And so first we're going to read the towers. And then we are going to read the instructions. And maybe we have like a new method called like move, and it's going to take in the towers. And let's actually try like a single instruction at first. So it's going to take in the towers, and then it's going to move some number of elements from some tower to some tower. So this is going to be the first arguments, right? Move 1 from 2 to 1. So move 1 element from tower 2 to tower 1. And then we can make expectations about the resulting tower. So now we can say we expect towers 0 .2 equal. So after we make that move, it should be ZND or something like that, like ZND, I believe. So let's run this. Undefined method move, we haven't implemented that yet. So let's say def move towers, and then we have some number, and we have from and to, and we actually don't want to do pop. We just want to do pop1. So pop is going to remove an element from the end of this tower, and this shovel operator is going to put it into the end of this tower. So we are operating on the tops. So this is kind of like our crane operator, but we want to do this n.times is like how many times we want to move something. Okay, we expected ZND, but we got ZN. So, all right, is this actually running towers.to? We're moving from tower 2 to tower 1. Ah, right, because this is going to be off by 1. So this is going to be, we want to just like follow the instructions, and the index into the array is not actually 1 based, it's like 0 based. So that should get us moving. All right, let's also make some expectations that it was properly removed from the other tower. So we're going to say this tower 2 should have M and C. So tower 2 should have M and C. Okay. And tower 3 should still just have P. All right, we'll run our example again. Okay, still passing. All right, that's fantastic. All right, so that moves a sort of like a single element, or like moves an element. And then what if we move all of the elements? So it works for the full test case. Okay, so then in this case, what we want to do is we want to sort of like move all. Let's make a new method called move all. We'll give it towers and the instructions, and then we'll expect that. Yeah, we'll write some expectations about it. But after we do, then what should we get? At the very end, we should get sort of this format. So expect tower 0 to equal just C. Expect tower 1, expect tower 2. So tower 2 should be PDNZ. PDNZ. It might seem like a lot to go and implement all of these tests, but I promise that it actually saves you time. I mean, I don't know. There's like these people who solve the advent of code problems super, super quickly. I don't know how they do it. All right, we got to go implement our move all method. And this is going to be something like, yeah, move for each instruction and to, okay, so we're going to call move for each of those instructions. All right, fantastic. Cool. All right, run this. Passing test. Okay, so now what I want to do is, let's say that we're only going to do this rspec auto run thing, like if argv is empty, and then otherwise we're going to read in from the file. So we're going to say like towers instructions is file.read argv, split on that, read the towers, read the instructions, move all from the towers to the instructions. And then there was one last sort of piece where we want to print out the like the last element of the tower. So towers.map last.join. I don't know, let's see if that works. And now we are ready to go grab our example input. So we need to grab our puzzle input here. Grab all of this, create a new file called input, paste it in, and then we'll say Ruby day 5 input. And this is our output, RLFNTB, blah, 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 which is the puzzle answer for part 1. Fantastic. All right, so we're moving towers around, we're following instructions, and it's all working. We could definitely refactor. I mean, we're 20 minutes deep into this thing, so not all of these work so quickly. All right, part 2. it turns out that the crate mover, or the crane called Crate Mover 9000, was actually a little dirty, and it's not Crate Mover 9000, it's a Crate Mover 9001. And instead of moving one crate at a time, it actually moves multiple. So when it's moving its crates, if you're moving, as we're following the instructions, instead of just moving one crate at a time, it's going to move that number of crates at a time. So we actually just have to make one small adjustment here, because inside of our move method, this is where it matters. So the reason we used the number n here, and we said n times, we want to pop off the top and put on the bottom, or move it from the top of one tower to the top of the other tower. And then it would kind of like do that n times. What that did was made sure that we were moving one at a time, n times. But now what we want to do is we're going to modify this for part 2. And instead of moving n times, we're going to move n elements. So we can use pop with an argument, and we can pass it the number that we want to pop off. And I think here we want to do plus equals, because we don't want to shovel an array in as an element of the other thing. We want to just move, we want to concatenate the existing tower that is going to receive the elements. We want to concatenate whatever's there. If there's 0 elements, if there's 5 elements, whatever, we want to concatenate what's already there with the elements in order from the other tower. So we're going to pop n off of the other tower. We're going to concatenate those on with plus equals. And so now the from tower will have n fewer. The to tower will be concatenated with the rest. And we can pop in our input here. And day 5 input. And we get MHQTLB whatever. Oh, boom, that's our answer for part 2. Okay, so it was just an ever so slight change in this move method. All right, let's talk about just a couple of different things. So the trickiest part, I think, of this solution was kind of deserializing the towers, maybe. There's also a lot of regular expression stuff going on here. So if you are unfamiliar with regular expressions in Ruby, I would highly recommend checking out Rubular. Rubular is like this really fun regular expression editor. So for instance, when we were talking about building the regular expression for this move from 1 to 2, here you can have like move, and then you can put your capture group in here, n, and that's going to be d plus. So now you can see that the match groups are n, and you can also see like, okay, this is going to match on move 1, and then you can say like, okay, from, and then to, and this is also going to be another integer. So now you're seeing the match groups show up, and you're also seeing kind of like your different test cases. So now you can say like, oh, what if it, was different numbers or whatever, like that'll show you kind of like the different matches as you go along. So Rubular, super handy. The other thing that was kind of interesting here, I guess we used reverse, and this is the first time in this year that we've used each with index, which again yields the index there. Anything else fun and funky about this solution? One other thing that can be kind of useful is instead of saying like instructions.each do with n from and to split up here, we could just say like instruction, and then I think we can splat that here, instruction. I don't know, it's like a super small little adjustment, but we get the same answer there, so that is working. I guess the other thing is that we finally got like RSpec behaving nicely with auto run inside of the same file, where we also have sort of this stuff at the end here. Yeah, so it is not the same like pure Ruby pipeline. There is a way to rewrite all of this to continue being a pipeline, but I thought it would be easier to understand if we broke it up into a few different methods, and also really easy to like kind of surgically come in and make changes for part 1 and part 2. So hopefully that was useful. Thanks again so much for watching and hanging out. Hope you're enjoying Advent of Code for 2022. And yeah, we'll see you next time. Cheers.